Mr. Jahandre, now
Yes.
all is set, I think. So I would like to start it now officially, and I will make the announcements. भाई इधर अपने कमरे का ख्याल रखने हमें इनको अगर पीछे वो रेडियो बंद करें वो जो आवाज आती है मेरा माइक सेंसिटिव है आ गया फिर आ गया जी आ गया जब नहीं था तो मैंने तुम्हें बताया था नहीं
Would you please give me 1 minute? I need
Please.
to
please
1 minute because my cat. I'm at home and she is hungry. I need to give him some food and I will come.
Okay, feed your cat first.
I'm sorry. Okay.
Yes, are you all set now?
Yeah.
Okay, now I will start the lecture officially. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum. Good afternoon from Pakistan Society of Civil Engineers in Lahore, Pakistan. We warmly welcome all participants, including those joining us on Facebook in lecture number 78, part of our monthly series that has been ongoing since 2020. Through these lectures, PSCE aims to provide both young and experienced engineers with the latest knowledge across various civil engineering disciplines. We encourage all young engineers to actively join us in our endeavor, as PSCE is a valuable platform for learning, networking, and professional growth. Before I tell you the topic, today's topic, and introduce the speaker, it is my responsibility to tell you the rules of this webinar as per the instructions given by Pakistan Engineering Council. The first one is registered participants for CPD points have to appear live on webcam. However, for the ladies, there is an exception. If they wish, they can cover their face while appearing live on the webcam. During the lecture, microphone of all the participants except that of the speaker shall remain in mute position. At the end of the lecture, there will be question answer session, 20 minutes question answer session, and the questions can be asked by typing in the chat box. And I will read those questions and inshallah, the speaker will answer those questions. And during the lecture, you can type the questions. And if there is any pertinent question, which I feel has to be asked at that time while the lecture is taking place, so I will intervene and inshallah, the speaker will answer that question. Participants on the Facebook, they have also the same facility. They can type the questions there. And one of my colleagues is monitoring Facebook. And inshallah, she will pass on the questions to me, which I will read for the speaker to answer. As you know, today's topic is regarding transmission lines, civil design of overhead transmission lines and overview. Now, before I give the introduction of the speaker, I must tell you that many professionals, including engineers, often perceive overhead transmission lines as a domain exclusively within the electrical engineering discipline. However, this is a significant misconception. In reality, the construction of transmission line is heavily reliant on civil engineering, with approximately 80% of the activities falling under this field. Key civil engineering contributions to transmission line projects include topographic surveys, geotechnical investigations, tower design, and foundation design. These elements are critical to the successful planning, construction, and long-term stability of transmission line infrastructure, underscoring the indispensable role of civil engineering in this domain. So this was just a note I had drafted for the young engineers to take into account while they are listening to this lecture. Now, our guest today is Muhammad Jahandre. He is an Iranian national, and he is today delivering the lecture from Tehran, Iran. He is an accomplished mechanical engineer with extensive experience in design, engineering, and consulting of power transmission lines and telecommunication towers. He holds a BS in mechanical engineering from Sharif University of Technology in 1990 and Masters in Mechanical Engineering from Shiraz University, which he did there in 1993. Mr. Jahandre's technical capabilities span wide range of areas, including preparation of overhead line design criteria, comprehensive surveying for route alignment, and detailed analysis using PLS-CAD. He specializes in structural calculations such as sag and tension charts, stringing charts, and loading analysis. His proficiency extends to the design of lattice steel towers and monopoles, as well as foundation solutions for diverse soil types, ranging from auger to spiral designs. With a keen focus on precision, Muhammad Jahandre has a strong command of developing fabrication drawings, structural erection plans, and bills of material. He also provides supervision for prototype assembly and testing, ensuring the reliability and quality of his designs. His work represents a seamless blend of technical innovation and practical implementation in engineering projects. So this was a very brief introduction of Muhammad Jahandre, and I now invite Muhammad Jahandre to please take the floor and start his lecture. Thank you. Mr. Jahandre, the floor is yours. Please start your lecture.
Okay, thank you, Mr. Sultan, for introducing me, and I say welcome to all audience to take their time to listen to my lecture. And you introduced me enough, I don't need to complete that. Thank you very much, and if you agree, I start the lecture.
Please start it.
Okay. Okay, can you see my window?
Yes, we can see.
Okay, this is what I have prepared as a mechanical engineer for introducing the role of civil engineers that is very impressive in design of overhead transmission lines. I give all the audience an overview and introduce from from the beginning for how to design the transmission lines and towers. As you may know, the transmission lines carry the electric power from one point to another point. And they have many types of voltages over the world. But the typical classification is three types of that. Well, that we don't consider the distribution lines because they have lower voltages and don't fall into category of transmission. We have three main classification. The numbers are will be different in different countries. We have high voltage, extra high voltage, and ultra high voltage. The high voltage for they are used for distances from 50 kilometer up to 150 kilometer, and they are at 63 kilovolts up to 132 kilovolts. The extra high voltage are 230 up to 765. The distance is between 115 to 800. And the ultra which are the very big transmission lines that pass the distances over 1,000 kilometers. The height of towers differ from by increasing the voltage level. Also, as you see, look at the table. I will not repeat. The bundle on conductor, I will explain about what is conductor bundling. The power losses. As voltage increases, the power losses decreases. So for HV lines, the power is moderate. For EHV, the power loss is low. And for the ultra HV, the power loss is very low because we need to carry the electric power at long distances. And the typical use of these are for HV. They are used in regional grids, EHV for national grids, and UHV for cross-country transmission. At the figure below, it's very simply shown how the electric goes from power plant. It comes to the increasing transformer, and then mounts on a high voltage transmission line, and after going the distance, they decrease the voltage, and by distribution lines, they bring the electric power to the homes or the end user. Okay, in this slide, we want to show that as the voltage increases, the size of the tower structure increases accordingly. For example, in the top picture, we have 45 kV, which is distribution. These shapes are scaled, and there is a scale height out here. You can compare the heights of transmission structures and lines, and also you can see the difference in heights of the same voltages. You see, at this, if you see my pointer, mouse pointer, we have 220 kilovolt by one circuit. Is lower height, has lower height than 220 kilowatt by with 2 circuits. I will explain about detail in next slides. But before all of the there is a advice from the PSCE standard. I copied and pasted these important because civil engineers may, to be clear about the nature of structural nature of overhead lines and structure. I read them very quickly. Overhead line structures are inherently different from buildings or most other structures. Overhead lines are a complex structural system composed of foundation structures, conductors, cables, insulators, and hardware fittings. A significant portion of the loads on the structure is imposed by the conductor and other cables strung between the structure, and the load is concentrated at specific points on the structure. The conductor and cables are subject to extremes of temperature, wind, ice, and other phenomena not typical to other structures, such as buildings and bridges. The tensions in these conductors and cables change with temperature, wind, and ice load. Another significant difference between overhead line structures, other type of structures, is that they are designed for a different life cycle than buildings, bridges, and other occupied structures. The structure designer shall clearly understand these differences and the unique behavior of overhead line. One advantage of this cable system is the combination of its ability to absorb dynamic energy with the very low relative mass of the structures. As a result, the design of overhead lines is not normally controlled by seismic loads because of low mass of the structure. Also, large structure deflections are acceptable in the transmission line, provided such deflections are accounted for in the analysis of the structure and their effects on the position of the connected conductors and cables are considered. Now, after introduction the transmission lines, we go to the key components. What are the key components of overhead transmission lines? Conductors, like ACSR, it stands for aluminum conductor steel reinforced. Or we have hundreds of types of conductors. Their role is to carry the electric power. And the second is ground wire. The ground wire's duty, they can be from simple steel cable, and also can be carry optical data. This is OPGW, or optical ground wire. They can carry the optical data through fiber. Their main duty is to protect the conductors against lightning. The insulator strings that are the intermediate between the conductors and the tower. The insulators that are used inside the insulator strings with types of glass or types of porcelain or silicone rubber that has the role of insulating from cable to the tower body. Hardware and fitting are different parts and steel parts used. I will explain you in the next slides. And also the supports, the towers, of course, are needed to carry the conductors and the ground wire and all other equipment. The towers itself need to install a foundation in order to be stable on the ground. In this picture, you can see the components. This is in the left picture. This is a transmission tower. And if you can see my pointer, these are bundle conductors. Each of these cross arms are one phase. So if we add three phases, three phases construct a circuit. So this tower has this transmission line is double circuit. It had two circuits, circuit 1 and circuit 2. These are cross arms. These are the insulator at the upper right picture. You can see the insulator strings attached to the cross arms. Types of them I will explain you later. So this is the intermediate insulator stick type pilot that helps to carry electric current from one side of tower to the other side of tower. Then at this picture, also I want to manage the time. These are different parts of the one. This is one circuit, single circuit tower. Here is the conductor bundle, insulator string, cross arm, tower window, waist level, and the different roles of the members of a lattice tower. They are horizontal members, the main leg members, main support, the most important members in the tower, and the diagonal. Okay, for determining one unique type of power, several categories should be considered, or combination of all of these gives us a specific type of tower to design in the transmission line. The first category is voltage. The voltage from these are voltages used in Iran, and of course, up to 400 kV, the 765 is under construction. As the voltage increases, the size and maybe type of the structure changes. For another category is number of circuits. We have single circuit, double circuit, 4 circuit, and more number of circuits. As I said, one circuit is 3 phases attached to the tower. The transmission line can be alternate current named AC or direct current named DC. The type of structure can be decided also. We can use lattice towers or towers in shape of webs, and maybe poles, and guide towers. Guide towers, I mean the structure is supported by cable. We can also change the material of a structure. Most of them are made of steel, or towers can be from concrete. I mean concrete poles. or maybe from wood. The wood can be are used in very low voltages in distribution lines. And also recently, the composite sections are becoming very used in the structure of towers. Also, there is important to determine the application of tower in line. What type of tower it is? Is suspension, tension, dead end, or transposition tower? I have some pictures here for showing the different types of towers. But return to this page. By combination of all of these together, you can reach for more than 1,000 types of towers, maybe 100, tens of thousands of towers. So if somebody wants to enter to this field of work, it needs to understand all of these conditions. Okay, we have from upper left, I see lattice single circuit. This is lattice double circuit. This is vertical configuration. The third is a delta structure. This is the type of how we configure the geometry of the conductors. We have here the guide towers supported by cables, so that for these types, the size of foundations becomes very small, and also the weight of towers reduces significantly for these types of guide towers. Also, we have poles. Here we have vertical configuration of poles, horizontal configuration, and delta configuration of all three are single circuit. Okay, the type of design of body we have here in this picture, we have monopole double circuit towers, and it is tension type because the insulator screens stay horizontal in the space. At this picture, we have suspension towers. You see the conductors are hang from the cross arm, not directly attached to the cross arm. And this is single circuit. We have very big towers. This tower has installed in India for passing through big rivers. There are special long span towers. This tower is has been installed in Iran. This is guide tower 400 kV and delta type. The type is similar to this configuration. And this is, you know, the tower near you see is tension type, and the other tower is suspension type. They are lattice towers. Double circuit lattice towers. You see these items between these are the hardware and fitting, as I explained in previous slide. These are spacer dampers. They take enough space between four conductors in order to not touching each other, and also damping against the vibration, air-induced vibration. In this slide, we introduce the two most important and famous standards in the world for transmission lines. They are design criteria for the transmission line. One should clearly should be familiar with these standards, especially working in the projects. After knowing and implementing all the contents of this standard, they are talking about how the loadings of also the strengths of different components of transmission lines, including cables, shield wires, towers, foundations, hardware, and fitting. If we have time, I can open these standards, show at least the topics of that. So IEC 600-826 is is somehow summarized, but BS standard 506-341 is more extensively explained in details about the criteria needed for designing the overhead lines. The components, I mean the component. Okay, all components of the overhead transmission lines are subject to environmental load conditions. Disregarding the effect of man. That means at the normal conditions, loading conditions. The loads, the old equipment have to carry dead loads or weights of equipment, weight of cables, weight of OPGW, insulator strings. They may be exposed to extreme wind. The other loading, they may be exposed to heavy ice in the absence of wind. Or the more important is the wind and ice combination on the conductors or shield wire that I have shown in this picture here. This circle is the cross section of the conductor, and a uniform or non-uniform thickness of ice, or I mean wet snow or dry ice can be settled on around the conductor, and when wind is blowing, the surface area affecting the conductor increases. And then, so considering wind and ice combination is very important in loadings of structures. Seismic loads are also may be considered in the design of transmission line structures, but as I told in previous slide, they are not play an important role in loadings of structures. Also, temperature variations, especially when temperature comes down before or maybe below -20 degrees. It causes to increase the tension of conductors and accordingly loading on the structures. In addition to the environmental load, they are also applying some unbalanced loads on tower structures. Unbalanced loads may include rupture of cables. Rupture of cables can happen because of maybe of the fatigue of the cables, or to be oldness of cables or heavy load. The cable may rupture, and as a sequence, the other cable that is not ruptured implies a longitudinal load on towers. The second is stringing loads. While erection of the transmission line, some stringing loads of conductors and shield wires may cause unbalanced loads on structures. We have maintenance loads, some hanging some heavy equipment on cross arms or other parts of tower. And also the man load, the man who climbs the tower with equipment can harm the individual members of towers. Okay, so we introduced here the load conditions. And as we explained about the loads on towers, and that they are applied to specific points of towers, point loads of towers should be calculated in order to design. The loads required to calculate the sag of conductor and tension of cables. It means in different climatic conditions with different temperatures, wind speed, and ice thickness, they can be must be calculated for obtaining the tension of cables. So we determine the load cases, how many cases we have the loads on them, and we calculate the values of loads in 3 dimensions on tower cross arms. For example, vertical load are due. The vertical loads are due to dead weight of the equipment. Transverse loads are caused by wind. Transverse loads are vertical in the horizontal situation, vertical to the cable because of wind loads and also angle of deviation of the transmission line. And longitudinal loads, it means in the direction of the conductors that may be caused by, for example, stringing case or rupture of the conductor. One typical table that has been, as an example, have been shown in one of towers I have designed. These load values are in kilograms, and that are ultimate loads together with the safety factors. Safety factors are used essentially for calculating the ultimate loads. For example, in high wind, we have some transverse loads and some vertical loads. But in the case heavy ice at item 3, you see we have much lower transverse loads and very much higher vertical load because of weight of ice. They consider also oblique high wind, wind and ice combination. And you can see that the table, this is the input of calculating loads on towers. We have also somehow we have asymmetrical maintenance. It means they are unbalanced to one side of tower. What is the software for OHTL designer? I normally don't mention some brand, but one and only effective brand of power line systems is PLSCAP and PLS4. And all over the world, more than 95% of the engineers, people use this software that is very extensive and very powerful for calculating transmission lines. It's the abilities of terrain modeling, terrain from point A to point E, that it passes from some mountains, valleys, hills. They consider all of them, models all of it in the software. It calculates the sag and tension of cables, calculates the loads on structures. They spots all structures one by one between the distance of lines. It also performs structural analysis and checking of the members of structure. Also prepares the output of drafting. They make from A to Z, all the design work of the transmission line. Here is the what the civil engineers should consider the steps for design of towers. First of them, determine type and dimensions of tower, as I explained in the previous slide. Create geometry in the software. It means the slopes, the points of cross arm, the size of members, size of components of the tower. Then calculate loads on tower. After that, structural analysis. Structural analysis, I missed one page I have prepared, is missed, I don't know why. Then, so structural analysis can be done by many software. So like SAP or Tower or MS Tower or StatPro or ANSYS, they can be used for structural analysis in order to reach the forces, moments, deflections, and foundation reactions of the structure. After that, we need to check the components of each structure. So for lattice towers, this standard PSCE 10 is useful and is very common to check the strengths of members of lattice towers. And for pole towers, PSCE number 48 is very clearly determine the criteria for checking the strengths of components. Here, you know, this lecture is an overview. I could not go to details. There is many items to discuss and to introduce. And up to this extent, I thought that this information would be informative for the structure. If you have any questions, I can help you if I could. Okay, what types of foundations we have? The towers are 1,000 types of towers, have 100 types of foundation. So we have here pad and chimney type. This is the pad, this is the chimney. And auger type, it means it is bored normally by hand, and it's cast in situ concrete. They have for it depends of type of structure and also very mainly to characteristic of soils. These, for example, mat foundation is a very weak soil, poor soil. Mat foundation, steel grillage, concrete piles. It can be precast or cast in situ. It can be drilled with the pile with helical piles, and it's with the micro piles by pushing, hitting the piles into the soil. Also, rock anchors here to insert into rock type soil. From my works, I have some pictures. These are from my works. This is the pad and chimney type. This here is the pad. The chimney is like this. The stop angle, you can see all the pictures. The stop angle is inserted into the concrete and is locked into the concrete because the tower could be assembled on the stop angle. These are all types of foundations that we drawn from the soil. This is the type of spread footing or pad and chimney, normally used for weak soil or poor soil. This is one of our my works about 20 years ago. Some these small towers are have very low back-to-backs, very low distance between legs that cause to overturning inside of the foundation inside the soil. So we needed to enlarge the distances of foundations with bigger pad and chimney. And thus, by this solution, we solved the overturning problem of the tower. This is auger board for good soil and also for rocks. These types of foundations can be used. Then this is can be excavated by hand, and also the reinforcement bars are set here inside the hole, and the concrete is poured around the bar in the situation. This is also one of my work. This is the for very weak soil we use mat foundation. Mat foundations are used. This is near a river. The tower is like this, and this is the foundation. One mat uh, below all on ground, and 4 chimneys getting outside towers, and then towers erected on the foundation. The last item I want to explain is about that the full-scale type test of towers are necessary for 95 cases, unless they have been designed for extra for considering extra loads. I mean, more safety factors. These are the pictures of my jobs in test stations. You see, in one test station, one prototype tower is erected with full scale, as he will mount it on the transmission line, and the cables together with the load cells are attached to the crossarm in 3 directions. As I explained, they have 3 directions. This is direction of longitudinal load. The direction, this is longitudinal load. This is the direction of transversal load. This cable, and also vertical load. For all of these, a load cell has been attached and is measuring the value of load that are applying, that will be applied on towers. The related standards for type testing is IEC 60652. It explains in details how to test the transmission towers. This is very important for the designer and also for the owner to see what is the safety factor of the design structure. And I very it's attractive to show you some videos of type tests, if you agree. Mr. Tahir, the contents of my PowerPoint is finished, and now I can show some videos from type test. It may be useful.
Yes, you can show the videos, but please make sure that you have to finish it within 90 minutes, your lecture. You still have time. I'm just cautioning you that you have one and a half hour for the lecture time and about 20 to 30 minutes for the question answer. Already I have 2-3 questions, but you continue, please. You can show your videos, no issue.
Okay. Okay, we have time, so I will show you the contents of the standards for designing that would be attractive for civil engineers, for designing the members. We have some videos of various type tests that is interesting to see when you see the last result of design of transmission structures.
Senden saçıyor. Oh, oh, oh. Wow. Wow. Wow.
Okay. Did you see all the videos? Yeah. Okay. So by seeing these videos for type testing of the towers, is it becomes very important to know exactly about the structure of the tower, about the calculations, about the design of connection. And as you saw from the videos, the failures are coming can be started from very local members up to total collapse of the structure. So as I explained, we have time, and I will show you the contents of the IEC 60826, the design criteria of the transmission lines, and some other standards.
Muhammad,
Yes,
uh,
yes,
I
please.
would uh, I would appreciate if you can very briefly describe in words the type of failures which is normally the wind failure which you have under the wind load, the failures have taken place. Just describe it for our audience, describe it briefly how the failures have taken place, most of the failures which you have shown in the video just now, just for their knowledge, clarity.
Mr. Tahir Sultan, do you mean about a specific video or for all of, because they are mixed
In
videos?
general, no, in general, what I could see that the failure was under the wind load, most of them. So just explain them what type of a failure and under what load these failures took place.
Yeah,
I
I will.
thought they were under.
Yes, I will explain. Mr. Sultan, you know that we have not all of the failures are because of wind load, because wind load is one case, and we have transverse loads. Transverse loads are because of become from the high degree deviation degree of the transmission lines. These are because of tension of cable. It can be uh, happened during the heavy ice also, during the wind and ice also. So normally, when we have load case of high wind, there is not a very critical determining case. The most critical case for all towers in the combination of wind and ice, and when especially for the tension towers, that for this case transverse loads is added by the tension of conductor for tension towers. And of course, as you saw in the video, that we have transverse loads. Is needed to explain about again the directions or not? If it is needed, I will show you. But transverse loads have two sources: one wind load, and the second is the tension of conductor. The longitudinal loads are also critical when the conductor is broken. So in some cases, it is not shown in the videos that what is the case. I have not recorded the case. But from the calculations, you can predict that at what case and what case is critical for the collapse of the structure and the weakness of the member. Is that is what enough or not? I will show in one of these. This is that you know this is a 400 kV single circuit tower. One of my designs was tested in Romania, and this case is the last case after. You know, in all videos you saw, the tower was past the test, and you see the failures when we start to increase the loads over 100% in order to see how what is the safety factor of the structure itself. And this is the case. This direction, if you can see my mouse pointer, is the transverse loads that wind on conductor and also degrees of the line deviation causes this transverse load. The vertical loads are obvious that because of the dead loads of conductors, and also here the shield wires, and also we have in this direction normal to the tower, that is longitudinal load. In this case, it happened 106% after passing all the previous load cases. It means that in this load case, wind and ice, we have 6% safety factor or structure in himself against ultimate loads. Taking into consideration that ultimate loads has their own safety factors. When we apply ultimate loads, it means that we have calculated in the applied loads already the safety factors according to the standard. Now we are very briefly going to the contents of IEC. This is very, very beautiful standard, and okay. It describes about, you see, forward scope, general design criteria, methodology, load strength requirements. We have no time to go into the details. Loadings is very important types section of this standard. How the loads must be calculated according to international IEC. The climate loads, combined wind and ice without wind. They offer formulas for this and also safety factors. And when you go to the details, you can calculate yourself all these loads. As I explained in the lecture, loads for construction and maintenance, that means safety loads. Loads for failure containment. This at section 7, it defines criteria, strengths of components, all components, it means. It means components of cables, uh, towers and structures, foundation. It has also annexes for formulations, for normative references. You can prepare this standard and start with this for studying this standard, for starting a right design and right formula, and please don't obey wrong ways for the calculation. Okay, after this, we go quickly to the other standard that I explained. It's about PSCE 50T41. As I explained, it is more very more. It has more details regarding to IEC, and is very useful. It's very detailed enough to, and is much more than enough. You see, most clients and consultants disobey this standard, but it's very accurate, very specified, and very reliable standard. It's English. It's English is very. It means they say basis of design, requirements of overhead line, basic requirements, or it takes time to study this standard. But my recommendation is to start with this standard, and because to select the right steps for improving your engineering way. They accept partial factors, actions are outlined, wind loads, wind forces on line components, all the components, wind of conductors, wind of insulator sets, wind on lattice towers. They have many details about these, and very beautiful and attractive for calculating for a designer. Okay, define the load cases, and then after that, they say the clearances, load cases for calculation of clearances. And they have useful annexes. They have also for materials, what materials are recommended for use, and what standards are used. I will explain later. So what are the steel lattice towers? Steel poles, above steel poles, basis of design, the standard. Wood poles, concrete poles. It's very informative, and can help you with different types of structures and equipment of the transmission lines. The foundation, they are explained about the criteria of the foundation. But as you know, you are all civil engineers and are much more expert than me, because I'm mechanical. I have very low experience for foundation design. Then after all of these, we have annexes. Annex statistical data for Gumbel distribution of extreme. This is the basic method for calculation of loads. Wind load, special forces, wind load, special forces. So I don't want to spend more time on this standard, but it's highly recommended to prepare this standard and start with these. In addition to start with the tender documents, a specification of the tenders or and so on. Angles in steel tower. Okay. One other thing I want to show you a very attractive field about one type of loading that let me see. Give me 1 second. I come. It's my flash drive that I want to show a video that one type of special loadings can cause vibrations on towers. This is one of my types that in such a special conditions that ununiform ice has settled down on conductors, and its combination with wind caused galloping, like the horse gallops, galloping of conductors. This is a suspension tower that the conductors are galloping in the transmission line. The ice has settled down on conductors and wind blows. You can see there is a dynamic load on tower. It is very interesting. It's very rare condition. So I want to show you the other standard showed in my presentation. That is ASCE 10, the design of. It's very useful, and it's something the basic reference of all of the world. Design of lattice steel transmission structure. Now it specializes about the lattice towers, and as a summary, I can explain about this. The lattice towers are designed for two conditions. One, the members of the lattice towers in tension conditions or members in compression conditions. In tension conditions, you have to calculate the net section area of the section, and then calculate the tension, and after that you can reach the strength of the member. For the compression of the members, they have some specific formulas. we have under section 3.6, this is the most important section of the ASC 10, and showing that how the allowable compression strength of a member of lattice tower should be calculated. Because as you know, as far as the length of member increases, its ability to buckling increases also. And here give some formulas for different sections, and these formula are the most important formulas for computing the buckling strength of members. For designers of lattice tower, I highly recommend to follow this standard. And for the steel port, we have ASC 48. Design of steel transmission pole structure, and gives very useful advices for determining how to combine the compressive force in the tower shaft, and also combine with the bending force and also torsional stresses. Defines how to assemble, how to erect, how to test, detailing and fabrication drawings. It's very useful and explains everything. You know, I from the beginning of my working experience, I started to first to study the standard, because it provides many important and safe steps for your progress in power designing. Okay, these are four important standards. IEC, this one, BS, this one, ASC 10 for lattice towers, and ASC 48 for pole structures. Let's go through some materials. What materials are used for structural steel? You know, structural steel, the materials are defined in this standard. Euronorm 125 is the most common in Iran, and also in European standard. The other important is ASTM. ASTM standard is for the material. It defines all the chemical composition and also test requirements of the materials, of the grades of material. I mean, I will go to the table, the famous table. Yes, these tables are for different grades, S235JR and so on. They give the chemical composition. In other tables, they give the hardness, and also the most important table is the yield strength. Yield strength, which is yield strength for design of structures, is the basis. that we cannot pass the yield strength during the design. Also defines the tensile strength of the material. This table is very important. And this is for the material and also for the bolts and nuts that are extensively used in a transmission line. The ISO 898 part 1 for bolts. Then ISO 898 for part 2 for nuts. And also 8 for part 3, 898 part 3 for flat washers. So I have gathered the standards for the strengths of sections, plates, and also for dimension. For high strength bolts and for the spring washers, flat washers, and
इधर बैठ जाओ हैं
for the nut.
अच्छा प्रिंट करके ले आओ मेरे पास ठीक है
Yeah. Okay, somebody now I finish my here because we have I don't know if we have some questions.
We have questions. Have you?
Okay,
Are you finished with your?
I finished up to now. Okay.
Okay.
And
Okay, one by one,
Mr.
I will
Sultan,
ask-
there is many problems to discuss, but in these 2 hours, going to more details is not necessary. We have no time for that.
No, you have done a very good job. I think people have got a fair amount of idea what is transmission line, how it is designed, and construction also. So now one by one, I will go with the questions. Most
Yes,
of the
please.
questions have come from engineer Suhail Kibriya. He is a very experienced engineer in Pakistan on the
Yes.
geotechnical side. He has an interest in transmission line also. So his first question is there a standard protocol for design of towers and foundations in Iran?
Excuse me.
I will ask again slowly.
Good.
Is there a standard protocol do you have any standards for the design of towers in Iran and the foundations? In Iran, he means Iranian standards.
Yes.
Do you have any Iranian standards
Yes,
for
we
design
have.
of towers?
We have Iranian standard. It is prepared by Ministry of Energy of Iran and specific for Iranian project. But for towers, we use ASC only. And the Iranian Ministry of Energy agrees with the ASC. And for foundations, there is not very complicated equipment, Once civil engineers familiar with soils and with the concepts of the tension, uplift, force of compression and uplift, can consider the slopes of the soil, and it can design the foundation with related safety factors. They are also explained in the PSCE 50341.
Okay. You have fairly answered the question, and this question has another part also. He's asking, do they have a pre-designed system of tower foundations? This is Mr. Suhail Kibriya means that in Iran, for specific types of towers, do you have any standard foundations, or you design the tower foundations every time you build a new line?
No, we have some predefined standard foundations. For example, Let me show in the presentation. I want to answer this. Is my, I want to, so mostly use the standards. I have shared my screen, I think. Did I share my screen? We have several types. This, let me explain by words. We have pad and chimney types for poor soils, and also for soils submerged in water. Pad and chimney, because it is very easy to construct. Also auger types for rock and good soil foundations. These two types are very, very common in Iranian types of lattice towers. For steel poles, we use mat foundations. One, how can I say? One bulk foundation for steel poles. Do you mean for lattice towers or for steel poles? We design specific foundation, but for lattice towers we use predefined foundations. Okay. Okay, next question.
Okay, I will ask the next question. Just I want to make additional comment. Suhail Kibriya, it is like this, that for the towers, there is a standard American Society of Civil Engineers, standard number 1041, PSCE. That is required that everybody follows for the design of towers. For the foundations, you can use the ACI code and other standards for designing the whatever is the civil engineering practice. It is the same everywhere. So you can use that civil engineering practice to design, as Muhammad has said, the pedestal, which is normally called chimney in transmission line, and its pad. So second question is again from Suhail Kibriya Muhammad. It is, in your experience, do you carry out soil investigation at every tower location? If not, what is the practice you follow?
Yes, of course, we need to perform the soil investigation, but not at every place, center of the towers. We categorize the types. We make the soundage, the holes for soil investigation from part to part of the transmission line, not for each tower center, because it would be very expensive, and make some safety factors for that.
Okay, I think you have adequately answered. Let me add to it, for the sake of the general audience, that the soil investigation normally in the transmission line, it is done along the line route at every 1.5 kilometer to 2 kilometers, and but at every angle tower position it is done. And then once you get all the data, geotechnical data of the transmission line route, then you categorize them. You group the tower foundations which have identical data, and then according to that you design your foundations for specific type of towers. So next question is, can you please describe, this is again from Suhail Kibriya, the question, can you please describe some failures and its repercussions in your long experience? So, have you understood the question, Mohammed? Can you
Yes.
please describe some failure and its repercussions in your long experience?
Describe about the failures. Yes. At my early stages of the design of towers, I had many types of failures. And then from that failures, I learned to improve my design procedure.
So he's asking the failures are normally at 45 degrees wind or 90-degree wind based on those loading charts. This is what he is asking.
Failure, yes, but you know, failure can be happened in any load case. Does not specifically related to 90-degree or 45, but at 90 degrees direction to the vertical to the conductor, the loads are much higher than 45 degrees. So for the 90 degrees is much probable for failure, and it's the critical case for design.
Okay, let me add to it also. So for the general audience, you see, for the when you are designing the tower, different load cases are prepared. These are called in transmission line language. These are called loading trees. There are different loading trees based on the wind coming in the direction in the 90-degree direction, one in 45-degree direction. When I say 45-degree, this is in the line of the transmission line, and then the seismic load is added in it, snow load, as Muhammad has already explained. Then we make different combinations, and which are called loading trees. Then all the loading trees are put in the computer software, and we see which is the most critical load. And based on that critical load, we will design the foundation. Now, another question is from Muhammad Nawaz. He's asking soft copy of the lecture. Muhammad, would you be able to give the soft copy of the lecture to Ms. Sadia so that if anybody wants, we can distribute it, or you have a copyright problem there?
Yes, sure. No. I prepared all of them by myself. There is no copyright problem. I can share.
Okay, Muhammad Mausam Nawaz, you can contact Ms. Sadia, and inshallah, as soon as she gets the copy from the speaker, he will pass it on to you. Is this topic described in Iran? You see, whatever the lecture Muhammad Jahanre has given, this is a general lecture of transmission lines, and it will be applicable in every part of the world. The standard, as I've said, you follow for the tower design is American Society of Civil Engineers. 1041 is the latest, I think, these days. So for the tower design, that is the standard. It will be applicable everywhere. And then we have foundation design. I have already said you will follow the general civil engineering practices to design the foundation. So now you have said, please have a scientific discussion on tower failure. As Muhammad has already said, it will take a long time to discuss the details and repercussions of tower failure. Maybe we can have another lecture on it. So it will be, we are already pressed hard with the time. So please excuse us. This question, it requires a very detailed answer. Am I right, Muhammad Jahanre?
Yes. Thank you very much for answering on behalf of me that, yes, for analyzing the failures of the towers, it means it requires a much more time spending. Yeah.
And this Suhail Kibria is again asking, did the failed towers met the design loading requirements of failed? You see, he is asking, Suhail Kibria is asking that the movies which you showed for the tower failure, did the towers failed at the design load or above the design load?
No, I explained about that. The failures
Okay.
were after after carrying all the loads and after acceptance of the tower structure, they go to destruction test. They want to know, after acceptance of the structure, how much safety factor of the structure we have against the critical loads. They are after 100%. Yes.
Yeah, thank you. Let me make it more clear for Suhail Kibriya. Suhail Kibriya, there is, in the specifications of any project, the safety factor is mentioned for the failure of the tower. So when the tower fails at a certain load, that load is compared with the design load, and then not the design load, the actual load which the tower will has to bear. So between the actual load and the failure load, the factor of safety is considered. Normally, 1.3 these days, or 1.25 is the factor which is acceptable. But in some cases, the factor can be high also. So this is a general answer to your question. Suhail Kibriya has again asked a question regarding this foundation design. Muhammad,
Yes.
he's asking, please describe the tolerance of total and differential settlements for the foundation design. So while you are designing the foundation, he means that the four legs, if they settle with a differential settlement, or the two towers, one tower with four foundations, another tower with four foundations, if they settle differentially, so how do you take care for that?
No, each tower acts independent from other. For the foundations, the type of it does not depend on two towers. It's the foundation type and size of design foundation depends of the reaction loads on the ground and also type of soil. That there is no difference. There is not. I can understand.
Maybe I didn't ask the question clearly. Please, I will now ask in two parts my question. One tower, it has four foundations. Okay. Now we
Yes.
design the foundations and tower is erected. Now, if one foundation settles down due to any reason, and the other foundation does not settles down. So what is for example, one foundation settles down by 20 millimeter and the other foundation remains there where it was. So how do you take care of this settlement?
Okay, of course, it will cause the failure of the tower at the long time.
After a long time. So he's asking, what remedy is in your mind at the stage when you design it?
What the remedy for the foundation, you mean?
Yes, that it should not settle differentially as compared to the other foundation.
So I mean, there needs to have a special solution, like shortening or adding tower members in order to compensate the settlement.
Okay,
Yes.
let me try, as we are shortage of time. So here it is, the differential settlement is normally we are taking in the design, not the differential settlement. The tower foundations are designed for a maximum 25 millimeters of the settlement. And if the area is weak, where settlements are, can be predicted that the designer foresees because of the soil terrain. So they will use a lean concrete below the foundation, a thick lean concrete, or they will replace the soil and with the gravel or with some other suitable material. So it is assured that the foundations do not settle. And let me also, for the sake of general audience, normally whenever a failure occurs in transmission lines, it is always because of the tower. In my career, I have never seen up till I am almost a 40 years old experience I have. I have never seen a foundation failing in a transmission line. Whenever there is a failure, 99.99% it is a tower failure. Okay,
Exactly.
next. Okay, thank you. And I go to the next question. On the average, what is the? Yeah, Sohail Kibria is asking, again, it is a question from, 1 minute. I hope I didn't miss any question. As per your practice in Iran, LRFD. Let me go to the other question. This, on the average, what is the, yes, he is asking, on the average, what is the percentage of cost of civil works to the total cost of transmission line? Similarly, what is the percentage of cost of foundation work to the total cost of TL? So can you guess what is the total cost of a transmission line based on the total cost of the transmission line? What is the cost of civil works? But in percentage,
It's
can you tell
around
any figure?
15%. It's around
Correct.
15%.
Yes, yes, correct. So I hope Sohail, you have he has answered your question well. So normally in a transmission line of the total cost, are you saying how much? 15% of the total cost of the transmission line or total cost of the project?
Total cost of the transmission line.
Okay, the
For a
15% is civil. Okay, civil works. Okay.
Yeah, yeah.
Okay. Now we have a
Excluding towers. It's
yes,
just for
excluding the
civil
tower.
work. Yeah.
Okay, okay. Now question is what is the frequency of towel failure? Again, this is Mr. Khalid Bashir who is asking this question. What is the frequency of tower failure generally worldwide and where it happens more? Khalid, this
Yes,
will be very difficult to answer, but let's
yes.
see if Muhammad can answer it.
Normally we consider the safety factors. Okay. And for 99% of the transmission lines, they work. Okay. So for the 1% remaining occasions, they have some problems such as shortages in members or damages of equipment or for the place that the climatic conditions are providing extra loads according to the calculations that are unknown, for special locations for hurricanes, special locations for some very big ices that are not categorized in the calculations. But for 99%, the safety factors are enough. Okay.
Khalid, what Muhammad has given an adequate answer. It would be very difficult to answer this question why worldwide where it happens. You see, these transmission lines are designed on a certain wind speed, which comes from the code, how much wind speed we have to take. For example, in Pakistan, whenever the wind speed exceeds 160 kilometers, you must have heard so many a tower has collapsed in that area, that area. So every year almost we are having a one or two towers failure in Pakistan. Not every year, I would say another, in every 3 to 4 years we have failures. And that is basically because the wind data, we do not have accurate wind data in Pakistan. We are using wind data from the American codes or the British codes. So ours in Pakistan, the speed which we calculate for the design is 160 kilometers per hour. Now there had been some failures in Pakistan, so we have increased the speed now to 180 kilometers per hour. And I'm sure the same thing would be in Iran also. So, and other countries also, in hurricanes in America or in Australia, towers must be collapsing when the wind speed exceeds, the design speed. Am I right, Muhammad Jahan?
Yes, exactly. Yes, you are right. Exactly. Yeah.
Yes, there is a last question. Is there any worldwide body to validate, certify? There is no such body, but as Muhammad has said, everywhere, almost in every country, we are using ASCE code 1041 for design of the towers. It's a very simple code and a very well written code. if it is a complete code for designing you don't have to go here and there for designing the towers. That is the best code, I think, available
Yes.
for design. Am I right, Mohammed Jahanre?
Yes,
Now
yes,
I
yes.
think we
It's
are
very,
completely. Yes, go ahead.
yes, yeah, it's very simple explained and is applicable and is very practical and easy and very beautiful code for working with. And very near to reality.
Yes, I agree. I agree with it. So now I have only 3 minutes left to close this session. Mohammed Jahanre, thank you very much. I was really impressed with the sequence of your lecture, the way you proceeded and the way you ended. That was excellent and very easy to understand. Your slides were in order and excellent. So I must appreciate your hard work for preparing this lecture. Very enlightening and had a very deep insight. It was simple also. In the beginning, it was quite simple to understand, and you touched some complicated issues also. So thank you very much for your time and your hard work. Now, I have to make some announcements, and after that, we will conclude this session. Next lecture is on 10th May. Sadia ji, 10th May, hai na?
It is 17.
May, huh? Just, huh? I'm sorry, ji. 1 minute. Okay, ji, the next lecture is on 17th May, 2025. The topic is pile design and construction practices, including aspects of pile integrity and dynamic testing. And the lecture will be given by Dr. Martin Larish. He's a very experienced professor and a civil engineer. He is based in New Zealand, and he will, inshallah, give lecture on the same time. Do we have the same time, Sadia? Time? Oh, we have not decided the time yet, but it will be when the advertisement will be publicized, then we will tell you the time. So hopefully it will be near to 2 p.m. Since with New Zealand we have a difference of about 6 hours, so maybe the time will be slightly ahead of 2 p.m. So we will let you know this, or a bit early of 2 p.m. We will let you know about it. So I repeat, next lecture is on 17th May, pile design and construction practices, including aspects of pile integrity and dynamic testing. Very important lecture, and I would stress and recommend all the young engineers, civil engineers, to please listen to Dr. Martin. He's a very experienced civil engineer, and he has agreed to deliver lecture on. He's very kind, and I must thank Dr. Martin for delivering lecture from our platform. Certificates will be those who are for the CPD, register for the CPD program. They can collect their certificate from 17th March onwards from our office, which is 14A1 Block B, Model Town Extension, Lahore. And person to call for collecting the certificate is Ahmad Akram. His cell number is 0347 462 5111. And Muhammad, your certificate and your shield, inshallah, Sadia will send you by DHL or some other. Must receive your certificate and your shield in another 2 to 3 weeks, inshallah.
Thank you very much. I'm very thankful for you, from you.
Yeah, I'm also honored on behalf of I'm again honored, and I must thank you that for this your time and for delivering this lecture with such deep insight. And obviously, everything cannot be covered in 1.5 hours. If you think that anything you want to say again, we can give you another time for the lecture, and it will be a honor for us if you want to say something on to give another lecture sometime in this year or next year.
Thank you very much. Let's see what happens.
My pleasure. Yeah. Now, as we come close to the today's program, I would like to express my heartfelt gratitude to all of you for being part of this webinar. Now, when we shall again meet on 17th May 2025, and I would also like to have my sincere thanks to my team, Sadia and Hasnan, whose hard work behind the scenes ensure that this webinar goes to you trouble-free, and the live telecast on Facebook is also smooth. So their efforts are truly appreciated. Thank you once again. Stay blessed, and Allah Hafiz. God bless you, Jahanre. Thank you.
Thank you. Thank you very much. Have a good day.
You too. You too.